Alright, welcome back. This is a continuation of the organic chemistry we started in our previous class. I remember I divided organic compound into aliphatic and aromatic, and I told you the aliphatic are the straight chain, and we said the aromatic are the ring, example benzene, which we will discuss later. And we divided the aliphatic into cyclic and acyclic, and I've been able to analyze the difference between the cyclic and acyclic. Now we want to pick the members under the acyclic, which is saturated and unsaturated. An example of the saturated is alkane, while the unsaturated are the alkanes and alkynes. Alright, now we will be considering them one by one. Each stand for a family and they have a general formula. Now, the general formula for the alkane is CnH2n plus 2. For this is CnH2n and this CnH2n minus 2. Now, if you check the difference, it's just 2. This is plus 2, this has no 2, and this is minus 2. So that helps you to understand the formula. Now, we'll be using this to write the name of each members. Now, when n is equals to 1, then the name will be met. When n is equals to 1, then the family, you just add met to the a. So that means we are just going to be, they all have the word a, in, and I. So when n is equals to 1, so here we'll be having C, H, 1 times 2 is 2 plus 2, 4. So this, then this, the name will be methane because it's met, then A, methane. This first member has no methane, there's no methane, there's no methane. They have no first member. Now the second member when n is equals to 2 is X. So if you follow this with the formula, you have C2, H6. Now that is 2 times 2, 4 plus 2, 6. That will give us X A. Now coming to this, following when n is equals to 2, you have C2, H4. That will give us X in. Now same formula, C2, H, 2 times 2, 4, minus 2, 2. So this is ethyne. Alright. Then when n is equals to 3, that is pro. So we have C3, H8, so that is propane. We have C3, H6, that is propane. We have C3, H4, H4, right?
Yes.
3, yeah, so H4, that is propane. Now, here when n is equals to 4, we have boots. So we have C4, H10, that is butane, boots, A, butane. Then we have C4, H8, we have butene, butene. We have C4, H6, that is butane. Now, your work is going to be much easier if you consider that each successful member differ by just 2 hydrogen. Each successive member differ. Each successive member differ by 2 hydrogen. So it makes your work easier. So when we have n is equals to 5, we have pents, like pentagon. So here we have C5, H12, the difference is 2. That is going to be pentane. We have C5, H10, the same thing with this difference of 2 hydrogen because they are homologous series. So we have pentene, C5H8 pentine. Good, we are doing well. Then when N is 6, when S is 6, we have X from the word hexagon, 6 sides. So you have C6H14. So you have hexane. C6H12 hexane. C6H10 hexane. So we have this till you have when N is equals to 7. So I can just rub this. So you can have it to the next point. So when N is equals to 7, you have X. When N is equals to 8, you have octagon. When N is equals to 9, you have none. When it's 10, you have deck. When N is equals to 10, you have deck. So you can go ahead and fill using this formula to fill the names. So from here we'll be having heptane, heptine, heptine, octane, octane, octine, nonane, 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 nonine. So like that till you write first to 10. For your O level, you don't need more than the first 10. So you must try to know the first 10. So in our next class, I'll be teaching you how to write complex name using this formula. That is what we call IUPAC nomenclature. So we'll be considering that. Then also next class, we'll be considering the difference between alkane, alkene, and alkyne. One of which is this is saturated, this is unsaturated, this is unsaturated. Then we'll also talk about their hybridization. Thank you. See you next.